Let me share my screen and then we'll start. All right, so we'll just start from zero again, right? Because we completed the syllabus, right? Because Sagar joined a bit late. So we done the entire module like discussion. We have done a lot of effort to understand about the routing, understand about the switching, understand about the basic networking. So what I'll do, because we discussed the previous all session in the Hindi, so we'll try to make some English discussion. I believe you guys are very much comfortable. There is no problem. So what I'm going to do, I'm going to start again discussion about the network fundamentals, right? So we'll discuss about the basic component of the networking. I'm not going to tell what is the CCNA, how the routing was going to be like look like, how the switching is going to be look like, because we have done a lot of discussion beginning of the 1 or 2 videos, the basic networking. So straightforward, because we already aware about the routers, we are aware about the switches, right? So I'm going to discuss about the like these component. So at least we can, get understanding what is the router, what is the switches, right? So in network fundamental, whenever we're going to discuss about network fundamental, we always having a provisions to understand about the network components, right? So when I started this course, right, so I just draw one of the topology, and in that topology, I just explain how networking looks like is nowadays, right? So let me see if that is available still in my whiteboard. Okay. Yeah, I believe it is. Okay. So I explained about this diagram during the very day one class, right? When I started this course. So that time Sagar was not there. So I explained, let's say suppose you are here, right? In your home, you might be having a computer. So how this computer is connected with the network, right? So to connect your computer with the network, we have to use two systems, right? Two medium means one is you can directly connect cable to your WAN router, right? That's your Wi-Fi router here. I'm using Wi-Fi router. And the second thing, you can directly connect over the air, right? Air media. Again, you just have to connect with the Wi-Fi router. So this is the two method, only two method. We can go with the wired or we can go with the wireless. There is no third way basically, right? So any connection, either we going with the coppers, either we going with the fibers, they all remain is going to be as a wired media. Any connection over the airs, they all are going to remain as a wireless media, right? So your computers, whatever the computer you have, these computers must be connected with the routers. This is the first requirement. Then only you are eligible, right, to get the internet. Else you are not eligible to get an internet. So if you don't have the connection, you are not able to get the internet, right? So now again, we have to understand why router is going to, required, and what are the type of the routers available in the market, right? So router and switch, we having a two type of devices. One is the router, one is the switch. So if I talk about the routers, right, router is something, if you see here in the diagram, right? So router is something we known as layer 3 device. Let me just use some other color here. So here I'll use this. So router always known as layer 3 device, and switch always known as layer 2 device, right? So we just have to understand this is the layer. This is the layer. So what does means layer? So layer, that means we having a two protocol stacks, right? If you, if I go a little bit down, we having the OSI layer and we having a TCP layer, right? So if I talk about the layers, right? So the physical layer in this OSI model, we having the total 7 layer available, right? But when we talk about the TCP IP, we having, let me see what is happening here. Let me just, so if I talk about the TCP IP, and this is the OSI model. So OSI is like something reference model, right? We can take as a reference, but you just think about the blueprint of any networking, right? So your blueprint is OSI model, right? But actual implementation is going to happen in the TCP/IP model, right? So whatever the TCP/IP you have, the actual implication or actual implementation is going to happen in the TCP/IP models, right? So in OSI model, we having a total 7 layer, right? Application, presentation, session, transport, network, data link, and physical layer. But in TCP/IP, we just having the 4 layer. One is the application, transport, network, data link, right? And we having the physical layer. So application, session, and presentation layer combined together, and that become the application layer in the TCP/IP model, right? But transport layer is always going to remain transport, even the TCP/IP, and the OSI model is also going to remain the same in the in network layer, also going to remain same as a both model, even the TCP/IP or OSI model. Data link is going to remain same, and the physical is going to remain same. So if I'm talking about the layer 3 device, so you just have to think I'm talking something about the networking. This is the layer 3. So this is the layer 1, this is the layer 2, this is the layer 3, this is the layer 4, and 5, 6, and 7. So you just have to go bottom to top. So the bottom layer always going to consider as a, your layer 0, right? Oh, sorry, layer 1, not layer 0. And the above the bottom, this is the layer 2, and this is the layer 3. So your router always work on the layer 3, and this layer 3 is known as the network layer, right? This is known as a network layer. Your switch is going to work on the layer 2, and this layer is known as the data link layer, right? So we just have to understand why network layer, why data link layer, right? We just have to understand why network layer and why data link layer, and what is the difference between the network layer and data link layer. So one thing we understand, if I am drawing something in red, like circle, that always represent to the router in networking concept. It always going to represent the router. If I am drawing this kind of a symbol, right, it always going to represent as a switch. This work on network layer, that is a layer 3. This work in data link layer, this is the layer 2. Okay. So if I am saying the network layer, if I am saying the data link layer, but still one layer is the physical layer. You can see here. So what is the physical layer? So physical layer is nothing. This is the PC1 and this is the PC2. If they want to talk to each other, so they need a cable. So this cable is called as a physical layer. So anything you physically connected between the two devices, right? So your router is connected with your home computer, your home laptop is connected with the router, or two laptop connected together with the LAN cable, whatever the LAN cable you have, they all known as a physical connectivity, right? So they're going to known as a physical layer devices, right? So you just have to understand this concept. So physical layer is something where you are just going to connect two devices, right? But once you connected the two devices, your communication is going to start with them, right? So the communication is going to start with the layer 2 first, because the physical layer is just going to provide the connection. Then your layer 2 come in the picture. So layer 2 basically whatever every device having their MAC address, right? Device MAC to MAC. So if I want to do the MAC to MAC communication, this is the layer 2. And these layer 2 basically also known as the VLAN based communication, right? I explained the VLANs also. I re-explain it. What is the VLANs? But you just understand VLANs when we talk, that is also understand layer 2 communication VLAN. There could be the layer 3 communication VLAN also, right? Which we call the SBI, right? I'll explain both the VLANs as well. No need to worry again. So MAC to MAC communication is going to happen. That is the data link layer. So always, whenever you're having the MAC, we're having a two types of the communication. One is the MAC based communication, and second one is the IP based communication. So in your device, if you see here, if you go in the device, every device they are having the MAC, right? IP configuration. If you're running here, you'll see here. See this device having their MAC. This is the IP address, and if you just run the command /all, you'll find this device having the physical address. So physical address is nothing. This is the MAC address. So even we having a two computer, they want to talk to each other. They required the IPs. There is no problem, right? They required the IP, but when they are going to do the communication, they will perform the ARP request, right? They are going to form the ARP. So what they are going to do with the ARP, they are going to do the ARP by the help of the IP. They will find out the MAC, right? So if you go and just check the definition of ARP, what is ARP? Right? So you'll find the very good, what is ARP, which called the address resolution protocol, right? So if you think about the ARP, the address resolution protocol is connected, always changing the IP address to fix MAC IP address. So if you're having a two PC, they want to communicate to each other, whatever IP they have, they will get the MAC address to do the actual communication between the devices, right? So you can see here, these are the PCs, right? So if you go in the PCs, see what is going to happen here. This PC host wanted to go this IP address. So they are requesting, I need the MAC address for this IP address. So if the router having that information or switch having that information, they will provide, then this PC will directly use the MAC to send the traffic to this particular PC, right? Because this router or switch might be having this information of the ARP mapping. So every switch, they maintain the ARP table. And by using those ARP table, they are going to process the packet from one port to another port, right? So that's why if I talk about the physical layer, this is the cable. Data link layer is nothing. Data link layer is your actual MAC to MAC communication, layer 2 communication, VLAN based communication. But when you talk about the network layer, this is the pure IP based communication. So all communication which is going to happen with the help of the IP, they are known as the network layer. So your MAC based communication is always going to be responsible by the switch, and the network layer is always going to be responsible by the router. So in everywhere in your scenario, you are going to get the routers. You are going to get the router in everywhere. Even you are the home, your router is going to connect it in such way. See, your Wi-Fi router is connected and your PC is connected, and further your router is connected with the ISP, and further your ISP is going to connect with another ISP and another ISP and another ISP, and then how internet is going to be formed. So internet is nothing, it's an interconnection of the ISPs. Means we having a lot of ISPs, and all ISPs are going to connect together, and they are just going to form an internet, right? So if someone is going to ask what is the internet, so internet just interconnection of the ISPs, right? So you are in the US, I'm in the India. So in US to India, we having a multiple ISP, they connected to each other. So why I'm saying anything here, my communication is reaching to the US, right? Because we having the dedicated media available via the C cables, and they carrying all the data traffic, whatever I'm saying, whatever you guys are saying from there, right? So this is how internet is going to work. So to route my traffic one location to another location, it's not easy. We required one of the device who understand the IP. So who understand the IP? The router understand the IPs because they are the network layer devices, layer 3 devices. So once my traffic reach to the router, this is going to redirect to the internet or ISP. ISP will further carry this traffic to another ISP, India to US, and then it is going to land to your router and it is going to connect it to your PC. So if I am saying from here anything, it is going to via this line and it is reaching to this. So this is how communication is happening even without using very larger routers. We are doing the communication, but still require the routers. So router is a very key component, right? It's a layer 3 device. It is going to understand the IP, and by using the IP, you can make the connection between the any two different geolocation to different regions or to different branch location, office location, whatever we have, right? So router is just layer 3 device. So one is the router is the home broadband. Another router is going to enterprise router. So home router, you might be have seen that. But if I talk about the enterprise router, right? So enterprise Cisco router, if you see here, right? So you'll find that enterprise Cisco router, these are the routers, right? So you can find a different model of the router. These are the Cisco routers. They having a similar LAN port. You'll find the WAN port. You'll find the power connection. You find the fans, coolings, everything will be there, right? So different models we have, right? Cisco router, if you search, a lot of models available in the market, and you can buy any of the router based on you. So there is a higher end of the router, there is a smaller end of the router, and these all routers are going to use based on your need, right? It is just going to use based on your need. It's not like it is not going to use. But if you're having the requirement for the more processing, more power, more powerful router, you have to pay more. If you're having the small office, low processing router going to require, you have to pay less. So it totally depends on the requirement, how much traffic you are just going to process via the routers. Similar, you just think about if you are just planning to buy any phones, so you're just going to pay more, then you'll get more storage. You're going to get more RAMs. If you're going to pay less, you are going to less storage, less RAM. Same concept is going to happen in the router as well. Okay. So these are the routers, and router, if someone is going to ask, this is something layer 3 device. So if you go here and try to explore what is a router, so you'll find more definitions. So see, these are all routers. These are the all routers, modem, router connecting these different things. And if you are going to see here, so router is device that provide the Wi-Fi. They are talking about the Wi-Fi, but there is a routers who not provide the Wi-Fi as well. They provide the direct LAN connectivity. Enterprise router, they not provide the Wi-Fi. There is two kind of the router. One is the wireless router, and another is a wired router. Again, so wired routers and wireless router. So wireless router, you might be finding the home routers. That is all wireless. Wired in the office. Office one is always going to be wired router. Office router is always going to be wired router. So this is how your routers and going to be used here, and the routers are going to be, make the connections with your local LAN or your WAN. So router is a media. Router is a media who is responsible to connect your LAN or WAN network. So what is a LAN network? What is a WAN network? You just have to understand what is a LAN network, what is a WAN network. So if I am going to talk about the LAN network, right? So LAN network is something in your office, right? And let me just LAN versus WAN, right? If you're going to search it, images. So LAN is something you are sitting in the building, right? So in your building, every PC is connected, your servers are connected, you connected, your printers are connected. They are all going to represent as a LAN, right? So local area network is something you are going to stay inside of your building network only. You are going to, so there could be the PC, there could be the user, there could be the servers, there could be printers, there could be Wi-Fi, WLC, APs, they all are going to be LAN. So you are going to talk within the building, within the office, you can talk. But if you want to talk another building, right? So these LANs is not enough to make the connection with another building. So you require the WAN. So you require the wide area network. So you require the routers. So routers are going to make the ISP connection, and they are going to connect thousands of kilometers, millions. I cannot say millions, but more than 10,000 kilometers, 20,000 kilometers. You can think any of the earth space where we having the living stuff, people are staying, we can connect them without worrying about the distance, because WAN is just going to carry all the traffic throughout the network. It could be the fiber, it could be the air, sea, every air it is going to carry the network, right? So the LAN is something you connected inside the office, and WAN is something you are extending your network and you're just trying to connect the remote location, other branch location. That is a WAN. So always LAN use the switches to connect the devices. All devices are going to connected within the LAN. That is the layer 2 device, which is known as the switch. So your LAN is going to use a switch. So the switch is responsible to connect the all your LAN devices. So what is the LAN devices? LAN devices, the PC, it could be the server, it could be the printer, right? It could be the AP, etc. Right? And WAN, again, if you want to connect, then you require the router. That is a layer 3. So router is responsible to connect the WAN. So this is the LAN and WAN and how the switch and router come in a picture. So if someone is going to ask the switch and someone is going to ask the router, you should know, right? Why use router? Why use a switch? Now they're talking about we having a two type of the router. Just so let's just suppose you are talking about the layer 2, right? If you're talking about the layer 3. So again, in this switching world, right? Switching network, we having a two flavors. Router, we understand router only to the IP. There is no other way. This only understand the IP, right? They can do the routing. They can connect the remote office location. Router is responsible to connect that, right? But when I talk about the switch, we having a two flavor. One is the layer 2 and one is the layer 3. So what is the layer 2 switch? So layer 2 switch is pure going to work on the data link layer. And this is not going to understand the IP. This understand only MAC, or we can say VLANs, right? But if I talk about the layer 3 switch, right? If I talk about the layer 3 switch, this layer 3 switch is very intelligent. It can understand the IP. It can understand your routings. It can connect your remote offices, likewise the router, right? Or it can understand the MAC plus VLANs. So L3 switch is, very powerful. It can understand everything for you. So now the question is going to come in your mind, why I can use the routers? I can use the layer 3. It can do anything. Yes, you can do it. There is no problem. Absolutely, you can use the layer 3 switch instead of the router in the layer 2 switch. Absolutely, you can use it. But it is only suggested for the small office location. Small office. Let's suppose you having the one branch, only 10 to 20 users are available. So you can do layer 3 switch. But if you're having the very large branch, you having the complex network, you require the very powerful routing engines, right? Then this layer 3 switch are not sufficient for you. You have to use the routers again, because the router having a dedicated routing engine, they will maintain the routing tables, they will take the quick decisions, they will process the larger number of the routes, because they having the higher capacity, just do the routing. But switching, again, they have to do the processing for the switch VLANs, they have to do the routing. So performance is going to be degraded in the larger network side. So it is always recommended just use just use routers for the larger network. So L3 switch is responsible to do, right, your routing plus switching both. It having the feature. A router can only do the routings, but no switching. But if we talk about the layer 2, it only do the switching. It understands the MAC plus VLANs. It's understand the MAC plus VLANs plus IP. Both. It understand only the IP. So this is the layer 2 and layer 3 switches, right? So if I try to show you the layer 3 or means the switches, Cisco switches, see how it is going to look like. Let me see where it's got hanged. My system got hanged, guys. Just give me a few seconds. Let me see if it's coming normal back. Okay, it's back normal. So if I'm going here in my Google and try to show you the switch, how the switch look like. So if you go here, Cisco switch, right? See, so these are the switches. So one common difference means one common not common, uncommon thing between the switch and the router. Switch having a too many ports. If you find the switch, you'll see a lot of ports are going to be available in the switch. So if you find a lot of ports on the device, you just guess this is a switch. But if you go on the routers, there would be the less number of the ports, might be the 4 ports, 8 ports, 6 port kind of the stuffs, but not like 24 ports, 48 ports, 96 ports. These are only available on the switch. Switch starts supporting from the 12 port to 96 port and more than that. It's totally depend on the capacity, line card, what kind of the switch you are going to use. So switches having the different models, all models having a different stuffs, and they all are going to support different port range, right? So switches having the always larger number of port, but if you go on the routers, they having the lesser number of the ports. So this is the common thing to identify. If you find two devices and you have to figure out what is the switch and what is the router, so just see the ports detail. You'll find the model also, but there is no written in the router or switch. But if you find the in port number, you can understand this is the switch or this could be router. Switch always having the low number of ports. There is no much ports is going to happen, right? So this is a switch. Switch can do layer 2, they can do the layer 3, they can do the routing, they can do the switching, but totally depend which layer 3 you want to use or layer 2 you want to use. Right? Any question till now about the router and switch here, or is it okay? Sagar, is it clear or?
Yes, sir, it's clear.
Okay. So now moving to the next thing, that is the firewall, right? So they are network fundamental. You should know about these components. You just have to understand, because the network fundamental, you just have to understand what are the different devices. So in next generation firewalls, right, and IPS. So what is the IPS and next generation firewalls, right? So if I'm talking about the next generation firewalls and IPS, so IPS and the firewall are interrelated. So IPS is intrusion prevention system. IPS known as the intrusion prevention system. And what is the firewall? So firewall, you can think about this way. Firewall is something is going to work as a gatekeeper. Any kind of the gatekeeper. Let's say suppose you are just working in any company, right? You're working for the any company. What is happening with this pan? So I don't know what is happening. Just give me 1 second. Okay, let me just use this one instead of the pen. This one. So this is the firewall, right? So firewall is a device. Again, it's a network device, right? Firewall is again a network device. But this firewall is something is going to keep checking everything, whatever the traffic is coming in your network, right? Any traffic if coming to your network, the firewall is responsible to check them, right? Likewise, the security guards, right? If you're having a security guard, the security guard is going to check everything for you. Everything they are going to check for you. Let's suppose anyone is entering your building, the security guard is going to check for you. Anyone entering in your building, so security guard is going to check for you. So if the person is not authorized, right, the security guard is going to deny them. No, you are not allowed to go inside. If person is allowed, they are going to allow inside the society or building or offices. Similar thing is a firewall. You build a network, right? You build a network, you connected the router, you connected the routers. Behind the router, you having a switch, right? Behind the switch, you having a different users sitting here. These are the users. These are the users. They are connected with the routers. This is connected with the internet, that is the WAN, right? So might be I'm the hacker here, right? I'm the hacker. I can reach from the WAN. I can try to reach to the this router, this switch, and then here is the one server. I can hack them server. I can hack them server, right? So nobody is restricting me. Nobody is asking me to stop because there is no security available in your network. There is no gatekeeper available. But if I use the firewall here, so firewall is going to inspect the traffic, whatever the traffic is going to come and try to enter. Firewall is going to check, hey, stop here. I need to verify you having the valid identity or not. So if you fail to provide your identity, it is just going to block you. If you able to allow your identity, then it is going to allow and you can access the traffic. So firewall is something is going to act as a security. So firewall is always part of the security, right? So security is something by using those security, you can allow the traffic, you can deny the traffic. You can allow the traffic, you can deny the traffic. And not only traffic, they can inspect, let's say suppose you downloading any kind of the file from the internet, right? This user is downloading some file from the internet and this internet file having the virus, this file having some kind of the worm, this kind of having any kind of the threat, this file having any kind of the vulnerability. This firewall is going to inspect those and might be if you're having the right policy, they are going to block at this level only. They are going to block the connection at the firewall stage only. So the firewall is very powerful. Next generation firewall, IPS is intrusion prevention system, the same thing, any virus, right? Any spying activity, spy means anyone is doing the spying activity, any kind of the vulnerability, right? Any kind of the attack, right? If these all things are going to happen, your IDS modules with the help of the next generation firewall, they are going to stop you, they are going to block you, and it going to save your network. It is just going to save your network. It is not something anybody can enter and anybody can do anything with your network, right? So it is just going to save your network. So your network will be safe, you will be happy throughout the journey. So the firewall is something, it is available in your PC also. Your PC also, it is having the firewall. If you just search it, firewall, you'll find the security firewalls. So this PC also having the similar kind of the rules. See, inbound rule means someone is coming out to in, you having the inbound rule. And in this rule, if I want to allow something, I can deny something, I can do that. I can do that. You see, here is the rules also. You can see we can define the policy also. If I want to define some policy, let's suppose this is the AnyDesk. If I want to block this AnyDesk connections, right? So I can block the connection. So nobody can do the AnyDesk to my PC if I block it from here. So this firewall is allowing someone can do the AnyDesk, but if I block it from here, it is going to block. So this is going to provide the security. So any application connection, let's suppose you want to packet tracer. Someone is doing the packet tracer. I want to block, no, it should not happen. So I can block it here, right? If you want to define a new rule from here, any custom application, you want to just block, right? Anything you want to block, you can just define the rule, define the action, and it is going to block, right? So this firewall is available everywhere. Your PC having a firewall, your network having a firewall, and the common next generation firewall we have, like the Cisco ASA firewall, right? Cisco ASA firewall. Palo Alto Firewall. Anyone saying anything? No? Palo Alto Firewall, right? So Palo Alto Firewall we have, and let me mute him. Palo Alto Firewall, we having the Fortinet Firewall, different vendor we having a market. So Fortinet Firewall, we having like Checkpoint Firewall. So these are the vendors. Most are vendors in market. There are a lot of vendors are in markets, and these are the different firewalls we have, and we can use them just protect our network. So if you want to see how firewall looks like, you just go on the Google and try to check it. Cisco ASA Firewall. It look like similar to the router. It's having the very less port, but they are not actually routers, right? So you can see here, they are the ASA firewalls. They're having very less port, right? They're having these all are Cisco ASA firewall. You can see here, this is Cisco ASA firewall. So you'll find written Cisco ASA and model number. What is the ASA versions? This is the front and back panel. You can see a lot of ports are available, but not like switch. So routers and the firewalls having a less number of ports, but switch having the very high number of ports. So next generation firewall is nothing. Next generation firewall and IDS module is something which is going to protect any authorized connections, any vulnerability, any virus, any kind of threats. These are the going to protect you by any kind of the malicious activity is going to happen from the internet. So these are the next generation firewalls, right? So if I want to go and learn the what is a firewall, what is the next generation firewall definitions, you can always Google. You'll find the similar kind of definition what I just told, right? So you can see a next generation firewall is a firewall designed to protect against the modern cyber threat and companies face. So cyber threats, what is the vulnerability, attacks, any kind of data leaks, any kind of the ransomware attack. These all things are going to be used, right? So anything like you want to protect by blocking the application, by allowing the application, inspecting the traffic, intrusion prevention system. See, again, it's a part of the next generation firewalls. So if someone is going to ask what is the next generation firewall and IPS, just you have to tell if I want to protect my network, so I need a firewall. What type of the protection it is going to give? It is going to give the virus protection. It is going to give the data leak protection. It is going to give me the vulnerability protection. It is going to give me the any kind of the attack protection. It is going to give the ransomware attack protection, threat protection, worm propagation protections, lot of things, right? So next generation firewall is a very powerful firewall, and now it is keep using everywhere in your network, right? So this is the next generation firewall, right? Now coming to the access point. So if you talk about access point, this is something we called as a AP. Access point we call as a AP. So if I talk here AP is access point. So there is a three component. Let me just write here AP, WLC, right? And third one is, okay, AP having a two flavor. Let me just access point. One of the autonomous AP, and second one is the light weight AP, right? And third one is the WLC that we known as the wireless controller. So wireless controller, right? So AP is autonomous system, right? Lightweight AP, right? WLC wireless controller. So we having a different AP and different type of the connectivity we have. So why we use the AP? So again, the fundamental of the AP is going to similar what we keep talking about, the Wi-Fi routers. So if I use the Wi-Fi routers, so these Wi-Fi routers having the antennas, right? These Wi-Fi routers going to have the antennas, and these antennas basically going to serve the signals, right? So let me just Yeah, this pen is getting a problem. So these are the antenna. You can see here, these antenna is going to keep spread the signals, right? But these antenna is okay for your home, right? These are the okay for home. So this is a Wi-Fi router. There is no AP is going to required. But your office is quite big, right? And a lot of floors will be there, a lot of blocks will be there, right? So a lot of section will be there. So do you going to install everywhere Wi-Fi router? The answer is no. If you're going to do, your management is going to be, very difficult, very complex. Troubleshooting is going to be very difficult, very complex. So this is not a good solution. So to mitigate this problem, what we can do, we can use the AP access point in every one or two in every section, every floor, right? Might be the access point is going to be installed, right? Just think about the access point. So these AP are going to be installed in the every floor, and this AP is going to radiate the signals in every area. So access point is something which is going to connect with the switch, right? And by connecting with the switch, they are going to spread the signals by different floor, different rooms, different areas, right? They all AP are going to manage by the switch. So they all need to be connected with the switch. Switch need to connect, right? So every AP need to physically connect with the switch. So your all AP is going to switch and they spread the communication over the air. And now you are sitting here in the laptop and they can enjoy the Wi-Fi. You can sit here with the laptop, you can enjoy the Wi-Fi. You can sit every block with the laptop, you can enjoy the Wi-Fi. So this is how switch is going to connect with the AP, right? So AP is something, access point is just used for the, spreading the signals, and they are going to connect the switch. So this is the alternative of the Wi-Fi, but Wi-Fi built access point with the routers, that is Wi-Fi router, but AP itself no having a routing capability, they just manage with the switch and they can spread the signals, right? So these are the APs. But these AP having a two version, one is the autonomous system, one is the lightweight. So if the autonomous system AP is, they having the individual configuration capability, means anything you want to configure here, you can do the configuration. If you want to manage them, you can do any kind of troubleshooting changes, you can do it from here. So if you have to change anything, like you want to change the IP of the AP of the any of the AP, whatever the room they connected, you have to log in each AP and you have to change the IP address. Anything, any small configuration you want to change, you have to log in each and every AP and you have to make the changes. But we having the lightweight AP, then probably you not have to do the individual AP configuration changes. We require another devices, which is known as a WLC. And these WLC is going to connect with the switch again, but they are going to manage these AP through the tunnels. So they are going to build the tunnels, and by building the tunnels, that is a TLS and DTLS tunnels. So if you want to do the any configuration, any troubleshooting, you have to go under WLC and you have to do all the troubleshooting and configuration of WLC. No need to go on the AP individually, right? So if you want to do the troubleshooting, let me just write here. So let me just here. So access point two type, right? Access point, that is a autonomous system access point, right? AP, and second one is a lightweight AP, right? So lightweight AP managed by WLC, and these type of AP, these are managed individually, right? So they are going to manage individually. So any configuration changes need to done on all AP, right? But here any configuration changes need to apply via WLC centrally. So this is how your life is going to be easy. So WLC here you can see this is the wireless controller. There is another flavor, DNAC based wireless controller. That is a DNA space we call. That is the latest DNA controller who manage the large number of the AP. So WLC is going to manage wireless controller. Wireless controller is responsible to manage the many access points remotely, right? You can do the config, monitor, right? Troubleshooting, etc. via the WLC. Via WLC. So if you're having 1,000 AP and you want to just manage them, troubleshoot them, you can absolutely do it. There's no problem. You can just do everything by using this WLC, right? So this is the WLC. So WLC, basically how the architecture is going to happen. So let me just summarize it here. So let's suppose one of the office, they're having the switch. This is your switch. This is your switch. Switch is connected with the let's suppose this is the buildings, right? This is the building block. This is the first floor. This is second floor. This is third and fourth. So first floor, second floor, third floor, and fourth floor. We deploy one AP here, one AP here, one AP here, one AP here. This is the AP. They are radiating the signals area, right? So access point is responsible to radiate the signal. Further, they are connected to the switch. And you want to manage them if they are the autonomous system AP. So no need to any WLC. But if you want to manage from the central lead for the configuration in all, so you need one device more, which is known as WLC. WLC will connect to the switch. And further, this switch is going to build a tunnel through the switch with all AP. This tunnel is known as TLS and DTLS. So you don't have to make a lot of pressure, just have to understand they are going to build the tunnels like this. These tunnel is based on the TLS or DTLS, right? And they are known as the cap WAP tunnel. So what is going to happen? All configuration you can do from here. T-shoot you can do from here. You can manage the logs from here, right? So everything you can, if you want to change any configuration on the APs, you can do via the WLC. No need to go individual to the AP. But if there is no WLC and you are managing the AP, all, so any changes you have to do, you just have to log into this AP individually, right? So this WLC can be DNAC based. So DNAC is something the next generation technology, what I just showed in my controller section during the network automation. So DNS center is something, again, a DNS space having a WLC, the concept is going to be same, but they having the latest technologies. WLC is a legacy way where we can connect the different APs, right? And we can connect them. So these are the WLC and controller, right? So let me know if you're having any question on it. So I'm just taking as a no. Now we having the question about the endpoint and servers and the POE, three things. So endpoint, if you're thinking about the endpoints, endpoint is nothing. Endpoint is what? Any device like PC is endpoint, AP is the endpoint, right? Servers are endpoints. Endpoints, that means printers is endpoint, right? Any kind of the IoT camera, means CCTV camera, that is also endpoint. IP phone, these are the endpoints. So endpoint is like laptop, any device which is just connected to the last for the end user, that is known as the endpoints. So endpoint is nothing, anything which is just connected for the users, right? PC, AP, server, printers, CCTV camera, laptops, IP phones, these are always known as the endpoints. So if I go here and I try to search endpoints, an image, you'll find that devices, it is literally endpoint devices, right? So if you anything you want to just understand, visualize, you can see what is the endpoint. See, these are the endpoints. Your computers, your digital printer, your smartphones, IoT camera, tablet, servers, smartwatch, laptop, computer. These all are in the endpoints. CCTV camera, IP phones, these all are the endpoints. So any device which is just responsible for the user to just use network, connect network, to just do some kind of browsing activity for the network, watching activity, for monitoring activity, they all are known as the endpoints. So it's very easy. So if you're using the smartphone, that is the endpoint. Your laptop is the endpoint. Your printer is endpoint, but your router is not endpoint, right? Your switch is not endpoint, right? Those are not endpoint because they are connecting the devices. They are not last mile. Last mile, something is the last. There is after your device, nothing is connected. That is a known as the endpoint, right? So what is a server, right? What is a server? So if I talk about the server, server is something, let's say suppose you're having a database, you're having the collection of movie. So earlier, right? We need some hard drive to store those movie. And whenever I want to watch movie, I connect my hard drive with the PC, right? This is my PC, and I can watch the movie, right? Because I want to store here. So your hard drive is basically acting as a server. You're storing, your storage capacity is large. Your computer doesn't having the storage capacity. Your USB drive, right? This is again acting as a servers because they storing the informations. So they having the limited capacity of the storage and they always need to connect with your device then to access. But now it is not happening. Now what is happening? Let's say suppose you using the Google Drive. So you using the Google Drive. So Google Drive, you storing your data, whatever you store movies, songs, your CV, your personal photograph and all. And what you need the internet connection. This drive you're not managing, right? It's hosted in somewhere in the Google. And you sitting here, right? Today you thought, let's open my Google Drive and see my old pics. So just go in Google Drive and see. So you can retrieve the information from Google Drive, you can see that. But the storage, you think this is something virtually, but your photographs is stored somewhere similar to your, hard drive or USB drive device. So those is big capacity. They having the higher number of hard disks. Might be you having the million of terabytes, trillion of terabyte resources, and might be the many terabyte RAM, right? So those are very high capacity hardwares where we having the many storage capacity or many people are storing their data there. That's why they become the servers. So if you think about the servers, so servers is, see, these are the servers. You can see it's a big devices hosted in data centers, right? They having the high capacity RAM, high capacity CPUs, and it can be accessed remotely. So server is nothing. Server is just big USB drive. See, this is a server. So they having the high capacity RAM, high capacity, hard drive, and you can access them via remotely. Likewise, the pen drive, likewise your hard drive, whatever you have. So if you go in server, what is server? You'll find a definition. So a server is a computer program, right? See again, or a device that provides service to another computer program or its user, also known as the client. In data center, the physical computer that server program run into the frequently referred as well. Means what that means? That means one of the bigger device, right? You can go there, you can execute you what you want to do there, and they will provide the output to you. So let's suppose first line a computer device or device that provide a service to another computer. What kind of service? So let's say suppose I have movie installed in my data center server, right? And you want to see the movie. So that computer will provide that movie to me. So that is another program, right? So that is going to help you. Server is nothing. Server is something which having the higher capacity. They will just redirect all the information, whatever you want to look from them. So this is a server. Server can be store your data center. It can be for the FTP server. It can be your SAP server. It can be your storage. You can photograph server. You can be your movie server. It could be anything. So server is just a big device which having the higher capacity RAM, higher capacity hard drive, and higher processor available. Those are the servers. So if you want to see the live in server, so let me see. I can show you. So I cannot show you. So let me just show you one of our Dell server to you, what I have. So Dell servers. So these are Dell servers. See, it looks similar to the computer, but they required, you know, I have this server available where we are doing the labs and all. So this server available with me. So it looks like simple device, right? We just have to give the power. They having the higher RAMs available, and prices are very high. Even it's a low configuration, but if you go and buy the higher configuration, the prices is going to be very high, right? So these are the different servers we have, and these servers are going to be, configured. So they see these are the different hard. You can see the slots. You can see these slots. Let me show you here. You can let me just show you. अरे यार कहाँ गया? Let me. You can see the first section. You can see there is regard to the hard drive SATA. So you can put the hard drive. You can see many terabyte hard drives. You can put these here. And if you open the upper box, you can. These are the hard drive slots. And these upper box, if you open that, there is a inside we having the RAM to install there. So we can install terabyte RAMs. Many terabyte RAMs. You can install a lot of slots are available, and processor are definitely very high. So these are the servers. So you can easily find. And what is a PoE? So power over Ethernet. So PoE is known as a power over Ethernet. Power over Ethernet. So why we use? So it's simple definition, right? We discuss about the access point. So access point need two type of the connection. First, they need the power to work, and second, they need the LAN connection, right? So if I have the access point, right? Let's suppose this is my access point. This is my access point. So if I want to give power, I need one port. If I need to give the LAN, I need to give the another port. So if this is the power and this is the LAN cable, this is the AP. This cable is going to connect with the switch because LAN is going to connect with the switch. And this power is going to connect with the power supply. So these APs are going to mount on the wall, right? So everywhere providing the two cables for the power and for the LAN is very difficult. And managing those cables is also very difficult. So Cisco come with the solution, right? Cisco come with the solution with the help of the single cable. Which cable? Only LAN cable. No power cable is going to require. With the help of the switch LAN cable, we can provide the power. We can provide the power. So this is the new solution. So to give this kind of the facility, they design a switch, that switch known as the PoE switch. So PoE switch, and we having a non-PoE switch. So PoE switch and non-PoE switch. So non-PoE switch, if you're going to use and you want to give the power this AP, then you require the additional resource to supply the power. But if you're going to use a PoE switch, this LAN cable itself, electricity supply is going to happen. So this is not going to required. So PoE means you want to supply power over the Ethernet, not need the physical cable. You not need the physical cable. So this is a PoE, right? So it's very easy. You can go here, Cisco PoE. It's a normal switch only. Cisco PoE, if you just search it. So you can see these are the normal switch, but they are the PoE switch. But if you want to get a non-PoE switch, you can buy Cisco from the non-PoE switch also. PoE switch is quite costly, and they always use to give the powers to devices. Kis type of devices we can give that, like camera. We can give the IP phones. We can give the IP phones power, right? We can give the access point. These devices, IoT devices, these devices can connect with PoE switch, which not required additional power supply. Power will go via Ethernet cable, RJ45 cable, Cat5 और Cat6 cable. So इसका मतलब ये होता है, right? So these are the devices we can use the PoE. So PoE is just for the power over Ethernet. So you should know, not much knowledge required, but you should know the meaning of devices. So what I'll do, I can stop it here for today, okay? And just recap this and try to understand what is a router, what is a layer 2 switch, what is a layer 3 switch. Try to Google yourself, okay? And find good definition. What I explained, try to recap the video, okay? Make your notes by going with the videos, right? And if you want to go with the books, also you'll find this available in the books also. Let me show you. So you can get the insight about this network fundamental, because these are the basic things in CCNA. So let me show you. See, so you can see here, you can go here and TCP networking, right? TCP IP model, what I explain, data encapsulation terminology. So you can start from here or you can start from here, right? So you can start seeing what is the RJ45 connector, how the NIC cards, what is the Ethernet ports, right? How the cable SAP is going to be connected, how the computer LAN is going to be connected. I explained this cable and all later state, but let me see the fundamental is showing here or not. I'll explain this cable and all later stage, but let me in LAN fundamental. Okay, this we'll discuss later. Soho and all. Uh, sorry guys, my network disconnected. Hope my voice is coming right. So foundation topic, right? So if you go here, see perspective of network, right? How networks look like, wired, wireless. These are fundamentals, right? So you can start from here. TCP networking models, right? How the internet connected. It's the same thing I explained, but they are more written. See the same data link, physical link, what I explained, but they are just talking about how server to PC is going to connect, right? How the data is going to be happen. So you can refer these books, right? Because they are explaining in more detail and theoretical stuffs, TCP/IP network, how networking looks like, how the emails communication is happening, how the same thing I just use for the voice reference, how the router is going to be communicate between the devices. So these are all available here, but you just have to invest some times, right? And you'll get the with examples they have written in the books. But you should know what is a router, layer 2, layer 3 switch, firewall, access point, and you just know the meanings. That's all. So can we stop today? Connect tomorrow again?
Yes, sir.
Okay, thank you. Thank you guys. See you again tomorrow. Bye-bye.
Thank you.
Bye-bye.